be continuing with the same Euclid's geometry concept. Okay. So yeah. First, let me know. Tejas, is it okay? Astitwa, Sazia,
Yes, ma'am. Fine.
Yes, ma'am.
Tara, Rumaisha, Irshad,
Yes, ma'am.
Ifra. Okay. Yes. Okay.
Yes.
Let's continue. Can you see the screen? How are you all?
Yes, ma'am. It's
See? How are you all? Well,
fine.
Fine, ma'am.
all good?
Fine, ma'am.
Okay. Have you revised till axiom number 4?
Yes, ma'am.
Ma'am.
So quick. I'll be taking the concept from the chapter polynomials. Okay. If anywhere, if you are not getting what I'm trying to explain, since I'll be taking it quickly, each and every concept, I'll try to cover all the concepts from the same chapter. So if you are not getting, you have to tell me that we need to discuss this in detail. Okay. So please let me know in between. So yes, the first concept, the very first concept in this chapter is, in this chapter polynomial is, how you will, or basically we are going to discuss polynomial in one variable in this chapter, one variable, but we must understand when we are talking about polynomial, we'll be talking about polynomial in one variable. Okay, so yeah, let's continue. First thing first, you should understand how to identify a polynomial. How to identify a polynomial. Now the question is, if I'm writing on the screen 1 by x cube plus 2, is it a polynomial? It's lagging, right?
No, ma'am. No, ma'am.
1 by
Yes,
x
ma'am.
cube plus 2, is it a polynomial?
Okay.
Tejas, yes. Who said no? Ishad said no, right?
Yes, ma'am.
Please turn on your camera, everyone. Yes, everyone, please turn on your camera. Sazia, Sara, Irshad, Ifra, Sitwa. Yeah, is it a polynomial? See, the answer is no, it's not a polynomial, because in first chapter you must have learned the law of exponent, and law of exponent says that a to the power minus m is equals to 1 by a to the power m. And if I have explained this chapter to you, then I have told you this formula is not only, this formula can be used to make the exponent from negative to positive. It is not just for that. Okay, whenever we are changing the place from numerator to denominator, from denominator to numerator, the term will reverse, this exponent will reverse its sign. If it is already negative, it will become positive. If it is already positive, it will become negative. So if you will write this 1 by x cube, why is lagging? If you will write this 1 by x cube, it will be x to the power minus 3 plus 2. Now the definition of polynomials say okay, if the variables are having exponent as a whole number, just a second. Can you hear me now?
Yes, ma'am.
Let's continue.
Yes, ma'am.
Yeah. So I was telling that if I have explained the first chapter to you, then I must have explained that a to the power minus m is equals to 1 by a to the power m. That means whenever we are changing the place of any term from numerator to denominator, from denominator to numerator, the power will reverse its sign. Okay, and hence this 1 by x cube will become x to the power minus 3 plus 2, and it is not a polynomial because variable's exponent is not a whole number. Here the variable's exponent, it's not a whole number, and hence it is not a polynomial. So whatever variable you are having, if that's exponent is a whole number, whatever variable you are having, the exponent of that has to be whole number, then only we can call it polynomial. Otherwise it's not a polynomial. Okay, let me turn off the video. It's lagging a lot. That's good. Yeah. So if we are having under root, this is also not a polynomial. Okay. Why? Because here x is there and the exponent of that is 1 by 2, which is not a whole number. Which is not a whole number. Now only I say to you, if the variable's exponent of variable, whatever variable you can see in the algebraic expression, that variable's exponent has to be whole number. If that is not the case, then it's not a polynomial. So far, is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay? This is not
Yes, ma'am.
polynomial because the power is 1 by 2, which is not a whole number. However, if we'll be having under root 2x plus 5, is it a polynomial? Is it a polynomial?
No, ma'am.
Yes.
This. Yes,
Ma'am.
ma'am. This one is.
Yes, ma'am.
This one is polynomial because again and again
Yes,
I'm
ma'am.
telling you that variable. Okay, the power of the variable, here the variable is x, power of that or the exponent of that is 1. Is that a whole number? Yeah. Yeah, we know that 1 is a whole number. Clear?
Yes, ma'am.
Yes, ma'am.
Let's continue.
Yes, ma'am.
Now the degree of the polynomial and the coefficient also. So whenever we are having 2x square plus x plus 3, is it a polynomial? Is it a polynomial?
Yes, ma'am.
Is it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Why it's lagging? Yes, it's a polynomial. Okay, it's polynomial. Okay, and here coefficient of x square.
Ma'am,
Coefficient of
what?
x square. What is the
Ma'am,
coefficient?
coefficient of x is 2.
2.
Let me rejoin. Okay, just a moment. No, let me rejoin. Everyone, please be here. Let me rejoin.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now this will not happen. Let me see. Yeah. Can you see the screen, everyone?
Yes, ma'am.
If I will give, if I will take one of the question as, if I'll take one of the question as u square plus u plus t, is it a polynomial in one variable? Is it
Yes,
so?
ma'am.
Yes, everyone. Is it a polynomial in one variable?
No, ma'am.
There is not one variable. We can see two types of variable over here. So it's not a
It's
polynomial
not a
in one variable.
polynomial.
Okay. So in this chapter, particularly here and in future also, whenever we'll be talking about polynomial, basically we'll be talking about polynomial in one variable. There has to be one variable. So the first criteria, the exponent of the variable has to be whole number. The second criteria, one variable has to be there. Okay. Now here comes the second concept over here, that is called the degree, like the coefficient of the polynomial we were discussing. So let me be clear, let me check whether everyone understand what is coefficient. This concept you have learned in the previous class already. Still, let me check. So suppose we are having a polynomial px is equals to, let's say we are having 3x cube plus 5. Now if I will ask you what is the coefficient of x cube over here, coefficient of x cube, who will say?
Ma'am,
Ma'am,
3.
3.
3.
Perfect. If I will ask you what is the coefficient of x square over here?
Ma'am, 0.
Yes, it will be 0. Okay, since we cannot see
Yes,
any
ma'am.
x square over here. Coefficient means whatever is multiplied with x cube, that is the coefficient of x cube.
Yes,
Coefficient
ma'am.
of x square means, coefficient of x square means, since we can't see any x square, so maybe there is a virtual, in our imagination there is an x square which is multiplied with 0. So coefficient of that is 0. If you want, you can think it like this, or straightforward way, if you cannot see that variable x square, that means coefficient is 0. If I will ask you what is the coefficient of x over here, what is the coefficient
Ma'am,
of x?
ma'am, it will also be 0.
It will also be 0. Okay, so coefficient, this concept is clear to everyone, right? Now the
Yes, ma'am.
next concept is degree of the polynomial, degree of polynomial. So highest power of the variable, the maximum, the highest power of the variable is called the degree of the polynomial. Whenever we are having a polynomial, for example, if we are having 3x to the power 4 plus 5x cube plus 2x square plus 5. Here, the degree of the polynomial will be the maximum power, the highest power of the variable. And here you can see the highest power of the variable is
4.
4. So this polynomial's degree it's 4. Okay. Similarly, if I'll give you on the basis of the degree, you understood maximum power, maximum exponent of the variable, that's called degree of the polynomial. Now on the basis of degree, each and every polynomial are divided into different, like each and every polynomial are having a specific name on the basis of degree only. Okay, so if I will ask you at first, I'm writing 2 and asking you, is it a polynomial?
Oh, ma'am.
No. Yes, ma'am.
Just I'm writing 2 and asking you, is it a polynomial?
Ma'am, no.
polynomial says that whatever variable you are having over there, that's exponent has to be whole number, and whole number starts from 0.
Yes, ma'am, it is.
Okay, whole number starts from 0. So maybe any variable is there, and that's power is 0. Exponents and powers chapter we have learned a to
Yes,
the
ma'am,
power
if
0
the
is
power
1.
is 0, that means it's 1.
In exponent and power rule we have learned a to the power 0 is 1.
Yes,
That
ma'am.
means 2 to the power 0 1, 3 to the power 0 1, x to the power 0 1, y to the power 0 1. So if just 2 is there, yes, it's a polynomial because it is fulfilling the criteria of the polynomial. Here you can think it like this: maybe any variable is there and that is having power 0. So yeah, it is fulfilling the criteria, exponent as a whole number. So yes, it's a polynomial.
Okay, ma'am.
And what is the degree of this polynomial?
0.
0. Okay, degree of this polynomial is 0. So this now on the basis of degree polynomials name we will be discussing polynomials. If the degree of the polynomial is 0, for example, our polynomial will look like any constant number, maybe 2, maybe 32, maybe 2000. If this type of constant number anyone will write and will ask you, is it a polynomial? So you will say that yes, it's a polynomial of degree 0. It's a polynomial having degree 0. Okay, now the specific name of this type of polynomial is, it's called constant polynomial. Constant polynomial. Or it's called constant polynomial, or it's called zero zero polynomial. Okay, you can see the name it's saying all about itself. Constant polynomial means just a constant number, or zero polynomial means degree 0 is called zero polynomial. Okay, now if the degree of the polynomial is 1, for example, our polynomial will look like 2x plus 3. Okay, or maybe 5x, or maybe anything. Okay, here the degree of the polynomial is 1. Here the degree, the highest power of the variable, you can check it, it's 1. Okay, this type of polynomial we will call it linear polynomial.
Linear polynomial.
When the degree of the polynomial is 2,
Li-
the degree of the polynomial is 2. For example, our polynomial will look like 2x square plus 3x plus 5, or maybe just 2x square plus 3x, or maybe just 2x square. These are different examples. Okay, example can look like this, or maybe this, or maybe this. X square term must be
Okay.
there. Why? Because the degree we are calling 2, the maximum power of the variable is 2. So of course x square has to be there. That's called degree 2 polynomial, and its specific name is called quadratic polynomial. When the degree of the polynomial, see, so far is it clear to everyone?
Ma'am.
Yes, ma'am.
Okay, let's
Yes, ma'am.
continue. When the degree of the polynomial is 3, for example, our polynomial will look like 3x cubed, and then x square term can be there, x square term can be there, then x term can be there, then constant can be there, or maybe it can be without any x square, x and 5. Even if only 3x cube is there, it is also the maximum, the highest power of the variable. It's 3, and it comes in the degree 3 polynomial, whose specific name is cubic
Cubic.
polynomial. Yes. Now, when the degree of the polynomial is 4, for example, our polynomial will look like x to the power 4 plus x cube plus 2, or maybe x to the power 4, 5x to the power 4 plus 2x, just that. Okay, x to the power 4 term will be there. That's when we will be calling it degree 4. Degree 4. Okay, and that is having a specific name called quartic. Quartic polynomial. This much only we need to know. We just need to know this much only. That degree, if the 0 degree is 0, that's called constant or zero polynomial. If the degree is 1, that's called linear polynomial. In linear polynomial, this x term will be there. Okay, or maybe y is the variable, then y term has to be there. Okay, that will not be 0. Similarly, in quadratic polynomial, it is degree 2 polynomial. Here, x square term must be there. X square term. Remaining terms are there or not doesn't matter. But whatever is defining the degree, that term will be there. Okay. Then only we will be able to call it degree 2 polynomial, and then only we will be able to call it quadratic polynomial. Now in class 10, again quadratic equation chapter will be there, and there I will tell you that remaining term are 0, that's completely fine, but in quadratic x square term must be there. Why? Because that is only defining the degree, and from the degree only the name is coming. Are you getting it?
Yes, ma'am.
Okay,
Ma'am.
so the
Yes, ma'am.
degree 3 polynomial, we don't have to memorize it because we already know degree 3 cube roots and all you have learned in the previous class. So degree 3 is cubic polynomial. This one will be there in your mind. Degree 4 is quartic, and degree 2 was
Yes, ma'am.
quadratic.
Correct.
Okay, so don't get confused between degree 2 and degree 4. Now the question will be like this, like there is a polynomial, I will write that Lx plus m, where L and m are constant. L and m are constant. This is a, which type of polynomial is this? Is it
Linear.
linear polynomial? Is it quadratic? Yeah, it's linear. Perfect. It's linear. Here degree is the highest power of the variable is x over here, and highest power of that is 1. And 1 means it falls in the category of linear. So far, any confusion?
No,
No,
ma'am.
ma'am.
Okay, let's continue. And how do so I told that it is quartic. Any confusion, Irshad?
No, ma'am.
Okay,
No, ma'am.
let's continue. Now the concept is zero of the polynomial. Okay, let me check anything I am missing over here. No. Zero of the polynomial. This is very, 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 very important concept, because this concept again, the whole class 10 concept, there is a chapter polynomial in class 10 also, and everything over there is based on the complete chapter over there is based on this concept zero of the polynomial. So if this part will be clear to you, then there you don't need extra explanation. Okay, so zero of the
Yes.
polynomial we will be discussing in detail. What does that mean? Whenever we are having, let's say I'm taking a example of one of the polynomial is px is equals to, let's assume that 8x minus 4. Okay, or maybe let me take one simple polynomial. Our polynomial looks like x minus 7. Now if I will ask you, what is that particular value of x which will make this polynomial 0, which will make the result
Ma'am,
0?
7.
7. X equals to 7. X equals to 7. If we will substitute at the place of x, if we will put 7, positive 7, then the complete result will become 0. And hence, this value x equals to 7 is called the 0 of the polynomial. So 0
Okay, ma'am.
doesn't mean that x value will be 0. 0 means such a value of x which will make the polynomial 0. Sometimes Sometime x value can be 0 also. If I will give you a polynomial px is equals to 3x, and again I will ask you, what shall we take at the place of x so that the complete result will become 0? What shall we take?
-3.
Is it -3? 3 into -3 is 0.
Ma'am, 0.
0. Here we need to take x as a 0 because 3 multiplied with which number will be 0? So 3 multiplied with just here is one number, that is 0. Then only the result will be 0. So here if we will take x value as a 0, then only the complete result will become 0. So x equals to 0. This value we have taken and have substituted over here. Then the result, the polynomial became 0. This value is called 0 of the polynomial. So 0 means, again I would repeat, 0 doesn't mean always the x will be 0. It can be 0 in some
Okay.
cases, but 0 basically
Ma'am,
means, yes,
if x is 0, so the value of x is 0, right?
yes, that is called 0 of the polynomial. In
Okay.
previous scenario, x equals to 7 is called the 0 of the polynomial. In this scenario, x equals to 0 is called the 0 of this polynomial, this particular polynomial. So such a x value which can make the polynomial 0, that x value, we will be naming it as 0 of the polynomial. Since you are making our polynomial as a 0, okay, your name is 0 of the polynomial. So whenever this terminology 0 of the polynomial will be there, you are not going to get confused. 0 means x as a 0. No, it can be in some cases x as a 0, but not always. Okay, so we understood what exactly is the meaning of 0 of the polynomial. Now here we will see px is equals to 8x minus 4 is there. I will show you the method of finding the 0. Every time we will not just observe and we will try guessing what can be that particular x value, what can be that particular x value. This way we are not going to guess it every time. So there is a proper method of for that, for finding the 0. Let me explain the method over here. The method is, whatever polynomial you are having, whatever polynomial you are having, just take that is equals to 0 and solve it for x value by using class 8 concept.
Okay.
Solve it for x value. Whatever you are having the polynomial, just take is equals to 0, make a equation and solve that equation by yourself and find the x value. So your x value will be
7.
7. And that was the 0. Just by observing, we have figured it out that that is the 0. So again, let me help you with the process because it is that important. Okay, so 0 of the polynomial means such a x value which will make this polynomial 0. But the process of finding the 0 is whatever you are having the polynomial, whatever you are having the polynomial, just take is equals to 0 by yourself. Okay, and then solve it for x value. What is the x value? Yes, what is the x value? Solve it by using class 8 concept. Solve this linear equation.
Ma'am, x equal to negative 1 by 2.
Negative 1 by 2. Yes. It's 1 by 2 or negative 1 by 2. It's 1 by 2, right? 4 will go to other side. It will be plus 4. Then 8x is equals to just 4. X is
Okay, sir.
equals to 4 by 8. So just 1 by 2. Okay. X equals to 1 by
Okay,
2
ma'am.
is 0 of this particular polynomial. If you want to recheck,
Okay, ma'am.
substitute x as a 1 by 2 and definitely your final answer will be 0 over here. If you want to recheck, you can recheck. If we are putting x as a 1 by 2, you can check it. We are getting 4 minus 4, and yes, our polynomial is becoming 0. So how we will be
0.
finding the 0 every time? Whatever polynomial will be given, that is equals to 0 we will be taking, and we will try finding the x value. Whatever x value we will be getting from there, that x value is the 0 of our polynomial. So we understood the meaning of the 0.
Okay.
We understood the process also. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Okay, now quick, we'll be solving few questions over. If we are having a polynomial px is equals to, okay, I'll be you just see how we are doing it on the screen. Tomorrow I'll give you time to solve the question. So if we are having this polynomial, let's find the 0. So we know for finding the 0, we have to take x, the whatever is the polynomial that is equals to 0, and we have to use our previous concept of solving the equation. We have to find the x value. So x value over here we are getting as a 0 minus 5, that is negative 5, and this x value whatever we ended up getting, this is called 0 of the polynomial. Anything else we have to recheck and do? No, nothing you have to do. When you are solving the actual question, you have to solve it like this. Is it clear to everyone?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
We'll be having px is equals to 8x plus 5. Whatever if we have to find the 0 of this polynomial, what we will do? We will take the polynomial and is equals to 0 we are writing by ourselves. Then we will focus on solving the equation, and whatever x value we will be getting from here, that x value we can say we ended up getting the 0 of the polynomial. Now even if someone will come and will try creating confusion by giving this type of polynomial, px is equals to, if the polynomial will look like let's say tx minus r, where t and r are constant, and will ask us what is the 0 of this polynomial, we will be able to find the 0. What we will do over here, with whatever is the polynomial, we will be taking is equals to 0, and we will try finding the x value. But here t and r is there, that also look like variable, but let me tell you that is not a variable. That is just like a number, that is a constant term. Okay, even if beside the question it is not written t and r are constant, even if this part is not mentioned, you have to take this t and r as a constant only. Okay, so t and r are constant just like a number, so we will try solving it. 0 plus r, 0 plus anything is just the same thing. X will be r by t. This x value is called the 0 of this polynomial. Are you getting it?
Yes, ma'am.
Yes,
Okay,
ma'am.
now if even if the question will look like this, px is equals to, let's say mx, just mx, and still if anyone will ask what is the 0 of this polynomial, m is the constant. Even if it is mentioned over here or not mentioned, we are going to take m as a constant only. So we will be using the same concept. Whatever is the polynomial that is equals to 0, then x value is equals to 0 by m. 0 by anything is just 0. We know that 0 by anything is just 0. So x value 0 is the 0 of this polynomial. You don't have to keep on thinking. You have to every time solve the equation like this for finding the 0 of the polynomial. Now let me know, so far any confusion to anyone?
No, ma'am.
No, ma'am.
No, ma'am.
Now the question will also be like this, that verify polynomial is px is equals to 3x square minus 1 verify. Let me write the instruction properly. Whether x equals to minus 1 by root 3 and 2 by root 3 are zeros of polynomial px is equals to 3x square minus 1. If if it is a zero of the given polynomial, yes or no. So we understand zero means such a x value which will make the polynomial the complete result zero. Yes or no? That particular x value, when we will put it, our result, the final result of the polynomial will become zero. Such x value is called the zero. So one by one we will be taking. If you are getting confused why two values are given, it's okay. Two value will be given. Okay. Little bit upgraded information is whenever the degree is 2 there will be 2 0. Whenever the degree is 3 it can be there, like we can have 3 zeros. Okay, so don't get confused when you see 3x values, 2x values. One by one you have to do. Okay, one by one you
Yes,
have
ma'am.
to check it. So if x value as a 1 by root 3, at first we'll be checking minus 1 by our polynomial is px is 3x square minus 1. 0 means when we will put this x value, the result we need to check whether the result is 0 or not. So 3x square means negative 1 by root 3 whole square minus 1 is equals to 3 minus 1 by root 3 whole square will be 1 by 3, right? Minus 1.
Yes, ma'am.
When we will cancel them out, we are getting 1 minus 1 because Bodmer says that first do the multiplication. That's why we are not subtracting at first. 1 minus 1 is 0. Now the value, x value which we have substituted, is it 0 of this particular polynomial? Oh yeah,
Yes, ma'am.
Yes, ma'am.
it's 0. Okay. Let's check the next value, 2 by root 3. That is also 0 or not? So px, we are having the same polynomial 3x square minus 1. Here we will substitute the x value as a 2 by root 3. Okay, and we will check the final outcome. The final answer is coming out as a 0 or not. Okay, solving the question part I'll leave on you from the next class. Today I'm doing it quickly. If not clear, let me know. So 3 into 4 by 3 will be having minus 1. 3 3 gone. 4 minus 1 is just 3. Is it 0 of this polynomial, the x value?
No,
2
ma'am.
by
No, ma'am.
okay, so the first value minus 1 by root 3 is 0 of this polynomial, but the second value is not the 0 of the given polynomial. Any confusion so far?
No, ma'am.
No, ma'am.
No, ma'am.
So 0 is done. Now factor theorem. The remainder theorem and division is not there in your syllabus.
Ma'am, what?
Remainder theorem and dividing. The dividing part is not there in your
Ma'am,
syllabus.
what is that?
Uh, in polynomial chapter, there is a concept, very important concept, that is remainder theorem.
No, ma'am. Yes, no.
It's not there in your syllabus. And
Let me
division
check.
of polynomials or algebraic expression, whatever you call it. This is also not there in your syllabus, but I explain these two concepts to my student so that when we are using the concept of factor theorem, they will not get confused. So you already know how to do the division.
Ma'am, it's not there in my syllabus.
I know it's not there. Okay,
Yes, ma'am.
I know it's not there. Since we are going to solve the question from factor theorem, which is related to factor theorem, I know that's why I have cut it. It's not there.
Factor theorem is there.
Factor theorem, since we are going to discuss it, that's why these two concepts you must know. Okay, then only factor theorem will make sense to you.
I have factor theorem.
Everyone has factor theorem. Okay,
No.
everyone is having factor theorem. Remainder and division is not even there in the syllabus. For everyone, it's not there.
No, it's not there.
Okay, you don't have Irshad factor theorem.
What, ma'am?
Ma'am, I think
Ma'am, I have factor theorem.
Yes. So basically, factor theorem, let me explain a bit what exactly was division, and you don't have to know the way. Okay, just a basic example I am taking, and I am trying to show you something. You don't have to understand completely the process, even if it is like not that clear, completely fine, because that part is not there in your syllabus. So suppose we are having, let me take a basic one, very basic one. Yeah, if we will divide 3x square plus x minus 1, this is a polynomial, right? It is a quadratic polynomial, right?
Yes, ma'am, it is quadratic
If we
polynomial.
will divide it with x plus 1, is it possible
Ma'am,
to
we
do
can
the
cancel
division?
x plus 1 and x minus 1.
Seriously, they just this x minus x plus 1, you are telling me to cancel them out or what? Okay. So the division you have learned in the lower classes, that we can divide 8 by 2. We can also divide 2013 by 2. We can divide it, right? Long division method we know. This type of division we know. So 1
Yes.
times 0, here also 0, then 1, here also 0, then 13 to 6 times 12, then the remainder is 1. So this method you have learned in the lower class. Now in this class, in the previous session, there was this concept was there. This time it is omitted from the syllabus, but also I want to show it to you, that we can do the division over here just like that division. So we can do the division. Let's do it quick. 3x square x minus 1. If you are not understanding the division part, no worry, I'm just trying to show you the remainder. Okay, what will be the remainder over here? So first we will focus on this 3x square and this x, and we will try asking the question, what should be multiplied, what should we multiply with this x so that we will end up having 3x square. Okay, so the answer is, if we will multiply 3x with x, if we will multiply 3x with x, the result will be 3x square, right?
Yes, ma'am.
So that's why 3x I have written in the quotient part, and here we are getting 3x square. But this 3x which we have written in the quotient part, that will get multiplied with the first term and the second term also. Okay, let me write what are we going to have the next step. So 3x we realize that we will multiply with x and we will be having 3x square. But 3x we need to multiply with everything, whatever is there in the divisor part. The divisor is not just x, it is x plus 1. So 3x, the quotient, whatever I have written, we need to multiply it with
Ma'am, I
everything,
have a
whatever
question.
is. Yes, please tell me.
If in the exam this question comes like this, can we use this one?
Question will not come like this. And if it will come like this, that means the question is asking you, demanding you to do the factorization of the numerator part, and then see if any common factor is there, then you can cancel them out by splitting the middle term.
Okay, ma'am, it's there, I think. So splitting the middle term.
So here we'll be having 3x square, and 3x will get multiplied with just 1, so we will be having just 3x. Now in our normal division we were doing the subtraction, here also we will do the subtraction, but two terms are there, so due to subtraction sign, each and every term will reverse its sign. Okay, if you will write minus of 3x square plus 3x, you should know that it will become minus 3x square, it will be minus 3x. Okay, so here we are going to change the sign. It will become minus 3x square and minus 3x. This two cancel them out, but here we are having x minus 3x. X minus 3x is minus 2x. Here we will write minus 2x and minus 1. Again, we would ask the same question, what we shall multiply with the first term of the divisor so that we will be getting minus 2x. Answer is, if we will multiply minus 2, the result will be minus 2x. We will be getting minus 2x minus 2. And this again will be doing the subtraction, and due to subtraction sign, the negative sign, each and every sign will get reversed. I'm just trying to show you the final result, the remainder. The remainder is, if you will do the subtraction over here, which we do in usual division, this minus sign will be plus and this minus sign will also be plus. This two will cancel out each other, and minus 1 plus 2 is nothing but just 1. So 1 is the remainder of 1. Can you see it?
Yes, ma'am.
I just wanted to show you the remainder. The whole process, even if you have not got, please forget about that. I just wanted to show you the remainder, that when we divided, now only I will leave you, give me 2 more minutes. When we will divide 3x square plus x minus 1 by x plus 1 by any method which is not there in our syllabus, the remainder will be 1. Okay, now remainder theorem, which is also not there in our syllabus, says that you just find the zero of your divisor. This is your divisor, right?
Yes, ma'am.
This is your divisor. You just find the zero of the divisor. Zero of this divisor. Zero of this polynomial. Okay. What is the zero of this polynomial? Who will tell me? Quick, quick, quick.
-1.
Negative 1. So x equals to minus 1 is the zero. Yes. Minus 1, right?
Yes, ma'am.
X equals to minus 1 is the zero of this polynomial. If this x value which you got from your divisor, if you will put this x value in the dividend, what is the dividend? If you are doing the division like this part is divisor, this part is dividend. Here you we write the quotient and here we write the remainder. So if you will put this x value in the dividend, you will be getting the remainder directly. That's what the remainder theorem says, that rather than doing the long division method, which is very long and very confusing, I am having a magical formula. That means you just find the zero of the divisor by using the polynomial concept and put it in the dividend. Directly you will get the remainder. So this is the dividend over here. Here at the place of x, if we will put minus 1, let's check what are we going to get. This will be 1 minus 1 square is just 1, so 3. Okay, here minus 1, here minus 1, that means 3 minus 2, that means just 1. And yes, remainder was 1. This much elaborated step we have performed to check the remainder, and yes, remainder was 1. So again I am telling you what I am trying to say. Okay, one time I am telling you in Hindi and then I'll be saying the same thing in English. So whoever doesn't understand Hindi, it's okay. I'm going to repeat it in English. I was saying that एक लंबा चौड़ा सा मेथड है जो कि डिवाइड लॉन्ग डिवीजन मेथड अप्लाई करके हम लोग देख सकते हैं कि रिमाइंडर क्या होगा. मैथमेटिशियन सडनली आए और बोले वो जो लॉन्ग मेथड है डिवीजन करने का, वो मेथड अगर नहीं, सिर्फ अगर हमें रिमाइंडर चाहिए तो फिर इतना टाइम वेस्ट करके क्या फायदा. अगर सिर्फ रिमाइंडर चाहिए तो मेरे पास एक छोटा शॉर्ट ट्रिक है which like which will give us remainder directly. Okay, I am having a short trick which will give us remainder directly, and the short trick is find the zero of the divisor and put it in the dividend. directly you will get the remainder.
Got it.
Find the zero of the divisor and put it in the dividend. Directly you will get the remainder. Process and all, if you need directly the remainder, find the zero of the divisor and put it in the dividend. Directly you will get the remainder. If this much a statement is making sense to you,
Yes,
then
ma'am.
we will be able to
Yes.
discuss factor theorem.
I understood this one, but not that.
Because factor theorem is check it whether x minus 1 is a factor of x square. Let me frame the polynomial. Yeah. Check it whether x minus 1, verify whether x minus 1 is a factor of this polynomial or not. Now directly if I will tell you that let's find x value from here and let's substitute it over there and then we will be able to say whether it's a factor or not, it will not make sense. Remainder theorem is that important. Check it whether it's a factor or not means if we will divide x square minus 2x plus 1 by this polynomial, if the remainder is 0 then yes it's a factor, if the remainder is not 0 then no it's not a factor. Okay, how we will be finding the remainder? By magical remainder theorem. Find the zero of the divisor and put it in the dividend. It will give you remainder directly. If that is 0 then you can say it's a factor. If that is not 0 you can say it's not a factor. Let's check it. X equals to 1 is the zero of this divisor of this polynomial. We will put it in the other polynomial x square minus 2x. 1 square minus 2 into 1 plus 1. 1 minus 2 plus 1. 1, 1, 2 minus 2. Yes, we are getting 0. But this was the method of finding the remainder. So this 0 is what? This is remainder. And remainder is 0. Can we say yes, it's a factor? Yes or no?
Yes, ma'am.
Yes, ma'am.
That's why that much basic was needed. I don't know why they have omitted the remainder theorem from the syllabus, but without knowing that, if directly you know this one, that let's find x value from here and let's put it over here, that will give us the idea that whether it's a factor or not. That means you are just learning the steps. That this is the step you have to
Yes, ma'am.
complete. Okay,
Yes, ma'am.
so I'm keeping it.